Welcome to C&EN Uncovered. I'm Craig Bettenhausen. C&EN Uncovered is a podcast series from Stereochemistry. In each episode, we'll take another look at a recent cover story in chemical and engineering news and hear from C&EN reporters about striking moments from their reporting, their biggest takeaways, and what got left on the cutting room floor. In this episode, we're talking about a recent cover story about the ongoing efforts to manage waste containing so-called forever chemicals, which appeared in the March 4th issue of C&EN. We'll put a link in the show notes. I'm here with C&EN's senior correspondent, Britt Erickson, who wrote that article. Hi, Britt.
Hi, Craig. How you doing?
Doing all right. So for anyone who hasn't had a chance to read the article yet, can you give a brief recap of what the story is about?
Yeah, sure. So this article is about PFAS. So you may have heard of these ubiquitous chemicals. It's a class of chemicals known as per and polyfluoroalkyl substances. It's kind of a mouthful, but people just call them PFAS. So I looked at how to destroy these ubiquitous contaminants in the environment and some of the startup companies that are commercializing new technologies to really get rid of these contaminants because they're everywhere. They're really a big problem in our drinking water. The US EPA recently put out some new regulations limiting how much of the most toxic ones can be in our water. And that's kind of driving a lot of this interest in how to get rid of PFAS.
Now, PFAS is an area of ongoing coverage for C&EN, and we've been covering this a long time. How did this specific story come to be? What attracted you to this topic?
Right. So about a year ago, I wrote about sensors that can detect PFAS in water. And I was talking with one of my sources from the EPA. And at the time, he said, oh, well, when you're ready to write about destruction technologies, we've got a lot of that work going on as well. So I said, okay, great. That'll be a really easy one to bang out because, hey, I've already got a source lined up and he's willing to share what the EPA is doing. Well, it didn't exactly work out that way. And so, I didn't get a whole lot out of the EPA, but what I did learn is that there's a lot of commercialization out there.
I noticed that. It's as far from the first time you've written about companies, but this was way more business heavy than a lot of the work you do.
And way more engineering and very technical, mechanical stuff. So I actually got a few tours and I went in and it was like a factory. You look at like Willy Wonka kind of factory with tubes and tanks and, just all kinds of plumbing and I don't know.
I love that stuff, man. So backing up a little bit, you mentioned that these PFAS have contaminated a lot of things. Where are PFAS being found?
I'd say one of the primary sources is from firefighting foam.
Okay.
So this was used, and it still is being used, at every major airport in America and every Air Force base. They were doing training exercises to put out fires with this stuff. And so, you spray all of this foam onto the surface, it rains, it leaches into the waterways. So a lot of drinking water, I think it's somewhere estimated about 40% of the drinking water in the US is contaminated with PFAS.
40%? I did not realize it was that high. Wow.
It's huge. Yeah. So I think, I don't know, I don't have the numbers exactly, but somewhere around 12,000 public water utilities are grappling with this problem right now.
Why do airports and military bases need a different firefighting solution? Because it's not being used by like the Baltimore Fire Department. It's
anytime you have a gasoline fire or a flammable liquid fire. The military has they have specifications on what can be called this AFFF. It's aqueous film-forming foam. Originally, it contained PFOA, which is one of the most toxic PFAS. So in the early 2000s, we stopped manufacturing PFOA, started making Gen X. So now most of the AFFF out there has Gen X, which we're discovering is pretty toxic too. There's a lot of firefighting foam. That's one source. But that's not the only source. A lot of consumer products have PFAS in them. Anything that's like water resistant clothing, rain jackets, carpeting, anything that's stain resistant, that type of thing. And the traditional frying pans, the non-stick frying pans, they have PFAS or Teflon. All of those products eventually end up in the landfills, and then the leachate from the landfills gets into our water. At the end of the day, the PFAS gets into our drinking water. And that's really where the EPA is concerned. We're being exposed to it primarily from our drinking water.
So broadly speaking, what are the goals of these PFAS destruction companies? Chemically, what are they trying to do?
So the idea is to turn something that's toxic into something that's less harmful. So PFAS are these long polymeric molecules with a bunch of carbons, and they're saturated with fluorines. And so to break that carbon-fluorine bond is really hard. It takes a lot of energy. So it's one of the strongest bonds in nature, and it's been pretty difficult. For a while, people thought it couldn't be done. That's not true. It can be done. Anything can be done with enough energy. So, fire and lightning, think that way. You need a lot of energy to break these bonds.
So when PFAS gets destroyed, what is left over? What are the less harmful things?
Yes, it turns into carbon dioxide, water, and fluoride ions.
Okay. So your article describes 6 different types of technologies for destroying PFAS. And I'd point listeners again to the written article where you got into the nuts and bolts of each one of them. They are electrochemical oxidation, supercritical water oxidation, hydrothermal alkaline treatment, plasma vortex, which is the coolest sounding one, UV photocatalysis, and underground sonolysis. Hopefully I got all those pronunciations right. But one question I had as I read through it is, are these all competing for the same remediation projects and the same PFAS removal sites, or do they all kind of fit in different places?
I think they're all going to fit in different places. There seems to be some competition. And the supercritical water oxidation, they call it SQO. So the SQO people, they're definitely competing with each other, but even within the SQO industry, they're all finding their own niche. So some of them are going after the solid materials versus the water. That made me think like another big source that people are going after are these military bases. So DoD has huge efforts right now to remediate the groundwater near Air Force bases.
So that's pulling it out of the dirt and the water runoff, that kind of a thing?
It's kind of like pump and treat right now. So you pump it out of the ground, remediate it. And my article talks about another technology, which is underground.
Yeah.
Because of the amount of energy that it takes to pump this water up from the ground. You eliminate that whole factor and make it more economical if you can actually treat it under the ground. So that's what she's trying to do. Michelle Crimmy at Clarkson University is working on that project.
And that's underground sonolysis.
Yes.
That name suggests they're using sound waves to do this work in that case.
Correct.
How does that work?
Good question. So she explained it to me basically like there's little cavities. And so like on ships, it's a real problem that it can actually like corrode the bottom of a ship when you get these little cavities of like, think of bubbles, but they're not really bubbles, but when you get enough of them, they implode. And when these bubbles implode, they make all kinds of energy and it's enough to destroy that carbon fluorine bond that we were talking about.
We mentioned earlier plasma vortex, which sounds awesome. Can you tell me a little bit about what that is and how that works?
The plasma vortex is one that OnVector is commercializing. And I actually visited OnVector up in, they have an R&D lab in Pennsylvania. It's not their main facility, but I was able to get up to that one and see some of their R&D work. So that one, it's like a cyclone. So I'm trying to see, it spins and you have a centrifuge and it all comes down into like, if you're following me, like a tornado.
Okay.
And so you spin it really big at top and then it gets smaller and smaller at the bottom and all the particles kind of go down and they get filtered to the bottom.
And so where is the plasma in that vortex? Is it like a line of plasma?
In the center.
Okay,
in the center of that vortex. And that's what's breaking it down. And then all the like solid particles get filtered to the bottom and they come out and precipitate out. The other type of plasma is, there's definitely more than two, but the two that I covered, there's one being commercialized by DMAX. And that was originally Selma Thagard at Clarkson University. And her team were working on, it's a water bath. And so in that case, the PFAS rises to the surface of the water, and then it's hit with this plasma on the top of the surface of the water. So it's completely different geometry. There's no vortex, there's no cyclone. It's somehow coming to the top.
So I'm going to make you keep the business reporter hat on for a second. Who's paying for this work? This does not sound cheap, but who is the ultimate customer for these technologies?
The big one is going to be Department of Defense. The states don't have any money, so they're not, don't look to the states. Chemical manufacturers are definitely interested. And I think if we can put some sort of technology in line with what they're already doing in their plants and make it all work together, I think that's the way they're moving. And they want to continue making fluoropolymers. And so if they are to continue doing that, they're going to have to do something to keep them out of the environment. They know that. The liability is way too high right now, the risk of being sued.
So I want to turn to some of the liability and regulations we've talked about. First, the kind of the why is how widespread are PFAS in the environment and people, and what does it do inside of you?
I think all of us have it. 99% of us have PFAS in our blood.
Does it help being way out on a farm in West Virginia versus being in the city in Baltimore like I am, or is it everybody?
I believe I probably have more than you. Huh. I live on a farm with a well, and our groundwater most likely is contaminated. I haven't yet. I don't have the heart to get it tested because I kind of don't want to know.
So what are the public health consequences of this PFAS exposure?
Right. So the health effects are still being teased out. We know that they can cause some types of cancer. I think the immune effects are probably the most subtle, then the hardest to get at, and probably takes the least amount. We're seeing changes in when children are vaccinated. If they have a high level of PFAS in their blood, they don't respond as well to the vaccines. Thanks. So it's doing something to our immune system. We're still learning about how that's all the mechanisms involved. There's a lot of debate over the toxicity of these chemicals. But we do know liver effects. It causes high liver enzymes in people, high cholesterol in some people.
So what kind of regulations and limits are already in place to protect everyday people or limit the exposure anyway to PFAS?
So for drinking water, some states have implemented very strict standards. And just recently, the EPA put out the first drinking water standard in nearly 30 years, and it's targeting 6 PFAS. So the most toxic PFAS, 2 of them, PFOS and PFOA, are limited to 4 parts per trillion. And that's about as low as you can detect them. The instrumentation just isn't going to go much lower than 4 parts per trillion. That's very low. So 3 additional PFAS. We have PFNA, that's the 9 carbon PFAS, PFHXS, so that's hex, like 6 carbons, and then the Gen X chemicals. So those are all limited at 10 parts per trillion. And then the EPA went a step further and set a limit for mixtures that contain any of 4 PFAS. So public water utilities have to comply with these regulations within 5 years. They have 3 years to do the initial monitoring to determine whether they have any of these 6 PFAS in their water. And then they'll have another 2 years to treat it if they need to meet the regulatory limits.
So you mentioned that there's a test, almost a bake-off coming up for some of these technologies. Tell me more about that.
Right. So that's coming out of the Department of Defense. They're going to do a head-to-head comparison of these technologies to see, where do they work the best, what front-end technology works best with what back-end technology, sort of pairing up different things, looking at the soil around Air Force bases, looking at the groundwater. And they're going up to Alaska to do some work, maybe to test them out to see if they'll work in a remote area. things like that. The DoD is really, I think they are funding a lot more of these technologies, and it's because, they're trying to clean up their own mess.
So who's in the bake-off? Who's in this competition?
So it's just Squo and Halt right now. But this is just one bake-off, right? So they're going to have more than one. Like all these other technologies that are a little bit further behind, they're also being demonstrated. And the DoD is just doing an amazing job of holding these demonstration projects for the companies, for researchers. They're at all different stages. So there's the research stage, then there's the almost commercial stage, and then there's the commercial stage. So it's like pilot and then commercial, but they're testing all three phases, right? And so there's projects going on all over, mostly at military bases where they're working on this type of thing.
So is there anything that you found in your reporting that didn't make it into the written article that you'd like to share?
Yeah, so one thing that really struck me was the number of women that I interviewed for this article. So typically on an engineering type story like this, you don't expect to get a lot of women. I think I interviewed 10 to 12 people for this article. Half of them were women. And not only that, there were 2, 3, 4 were CEOs. And so they were really passionate about what they're trying to do. Right. So like I said, it's not just the money, but they also have this passion that they want to clean up this mess that's out there in the world. Some of them had small children. Some of them were pregnant, about to have more children.
So from the 10,000-foot view, how close are we to developing a sound strategy for removing PFAS from our environment?
It's going to take a really long time. We keep producing it. That's one thing. Until we stop making it, we're never going to, unless, maybe we'll make ones that aren't toxic. I don't know. But I feel like we're always going to have to keep cleaning it up if we keep making it. But, there are benefits to these products. So I wouldn't want to go out in the rain without a raincoat, personally. Right. I mean, my children do. It doesn't seem to bother them, but... I think the technologies are there to help us, but it's going to be, there's so many different types of contamination too. There's not just one PFAS, right? We didn't talk about this, but there's depends on who you ask, between 4,000 and 15,000 PFAS chemicals. So that's a lot of different PFAS. And we're only talking really about 6 of them that the EPA is regulating in drinking water.
That's a big difference between those two numbers. Britt, thanks for diving deep with us on this. It's really interesting stuff.
Oh, thanks, Craig. It was great to be here.
So listeners can find me on social media as @CraigofWaffles. What's the best way for them to reach you?
Probably email is the best way to find me. And you can find my email if you go to my bio on our website.
So you can find Britt's cover story about managing forever chemicals on C&EN's website or in the March 4th print issue of C&EN. We put a link in the show notes along with the episode credits. We'd love to know what you think of C&EN Uncovered. You can share your feedback with us by emailing cenfeedback@acs.org. This has been C&EN Uncovered, a series from C&EN Stereochemistry. Stereochemistry is the official podcast of Chemical and Engineering News. Chemical and Engineering News is an independent news outlet published by the American Chemical Society. Thanks for listening.